Okay, hi everybody. Hope everything's going okay up to this point. Today, what we're going to do is we're going to kind of take a step back a little bit, and we're going to go through and we're going to examine solving exponential equations. So I want you to take a look at both A and B, and you'll notice that my variable is up in my exponent. And so we had means to be able to go through and solve this at the beginning of the unit. So take a look at question A, and I would hope that everybody would be pretty quick to be able to say, for me to get my variable out of the exponent, I need a power equal to a power base the same, and therefore I can state that my exponents are equal, and we're good. Now, you take a look at B, and I want you to notice that's not going to quite work the same way. It's very difficult for us to go through and write 18 as a power base 3. Although we could estimate that solution. The idea that we're going to get 2 point something, right? 3 squared is going to give you 9. 3 cubed is going to give you 27. And so 3 to what exponent gives you 18, somewhere in between. We know we've got to get 2 point something. What we want to examine now is what would we end up getting for us to be able to go through and solve. So for us to know that our solution's got to be 2 point something, we have the means and a new means to be able to solve that equation. If you're to take a peek at the solution to B, you notice you have to get your variable out of the exponent. And we have a new way to do that. And if we use our property of logs from yesterday, if I were to take the log of both sides of my equation, I've done the same operation to both sides of my equation, so my equation stays balanced. But notice what I have on the left side. I have a single power inside my log, and I know that that means that I can move my exponent out in front. That would allow me to write to this line, and I want you to notice that we've cured our problem. For us to be able to go through, my variable is now out of my exponent. I can solve that. I want you to take a peek at one key feature. I do have this log 3 that's attached to my x by multiply. And I know that I can get rid of anything that's attached by multiply by dividing. Now just notice that log 3 is a number. You can punch it into your calculator if you like. It's an ugly number, but it is just a number. So for me to get rid of that times by a number, I can go through and I can divide that out. And so I'm going to get down to a value of log 18 divided by log 3. Now, let's take out our calculator and let's push some buttons if we can. The only thing to be very careful of is when you go to punch in log 18, I want you to notice to see whether your calculator opens up a bracket or not. If it does open up that bracket, make sure that we close that bracket before we type in log 3 to make sure that we're dividing by log 3 and that we don't end up creating a log inside of another log. So check your keying sequence and we'll notice that we get down to 2 point something. I want us to take a look at that solution that we just used in B, and we're going to do a quick proof for it. So over on the right side, what I'm going to do is I'm going to deal with the most generic exponential equation I can. And I need to now solve for B. So since everything's a variable, it's going to be difficult to write C as a power base A. So what I can do is I can take the log of both sides. Now that I have a single power on the left side, that's going to allow me to bring that exponent out in front. And now for me to get that B all by itself, I need to divide out my log A. And so if we can take a quick peek, you'll notice that we have the exact same process that we just went through in blue. I want to add in one other key feature to that equation. That's very important. This decision on this line to take the log of both sides, notice what base we took that log with. Base 10. Why did we take base 10 on both sides? Because our calculator has every log base 10 programmed into it. That was a decision for us. It's important to notice we could have taken the log of any base on both sides. So I'm just going to slide in a little log base d. And for me to be able to go through, that means each of these would have been a log base d. And so my actual proof would look something like that. That I can take the log of both sides from any base I wish and be able to solve. You'll see that if we back it up and notice that there really are base 10s there. We now have a new way to be able to go through and solve. If you're still a little kind of hesitant on it, go back and tackle A again. And notice that you could take the log of both sides, bring your exponent out in front, divide out your log 2, and when you punch that into your calculator, you're going to notice you get a value of 3. Just a little confirmation. Now what we want to do is we want to take that strategy and we want to see where we can apply it to some uglier equations. Now we're going to take a look at problem C, and problem C is going to look significantly uglier. I want to walk my way through how to solve that equation using a new strategy. First part is I have to solve for x, and I notice where that variable is. It's up in the exponent. That means I have to get it out. And so my first look is, can I get a power equal to a power base the same? It's not going to be very easy to write 130 as a power base 5, and so my decision pretty quickly becomes I'm going to take the log of both sides. Now that I have taken the log of both sides, and I notice that on the left side I have a single power inside my log, I can move my exponent out in front. Now I want you to take a look at that line that I just wrote, because there's an error in it. This is going to be a common mistake for us, and we have to be very focused on it. Notice up in that first red line, I have 2 terms in my exponent. And if I have 2 terms in my exponent, then I need to make sure that I bring that whole exponent out in front, and I attach that whole exponent by multiply. So make sure that we have brackets around that entire exponent to make sure we have the correct operation. Now that I get to that point, I'm going to step aside over onto the right because I want us to see that that's actually a grade 9 equation you have sitting in front of you. What I'm going to do is I'm just going to make an alternate equation here so we may be able to see it a little bit clearer. I'm going to say, let's replace my log 5 with just like an easier number, like 5. And let's replace my log 130 with an easier number, 7. I want you to take a peek that those 2 equations in red and blue are the same. Log 5 is a number, an ugly number, but just a number. As well, log 130. So in blue, you'll see I just replaced them with 2 other numbers that are easier to work with. Now, we examine that. Let's jump through. Take a look at the blue equation, and what would you do to be able to solve that blue equation? Well, because that 5 does not divide into the 7 evenly, we're probably going to go through and expand that 5 into the brackets. So let's do the same thing with this equation. That's going to give me a 2x log 5 plus a 3 log 5 equals log 130. A small note. Notice the way we write that. When I took 2x and I multiplied it by log 5, we write it as 2x log 5 because then we don't need brackets. I do want you to notice how it can get a little confusing if I had written it as 2 log 5 times x. A question arises. Is this x inside the log, or is it 2 log 5 multiplied by x? The way we can avoid all the confusion and having to avoid writing unnecessary brackets is to write it in this form. Okay, if I take my blue equation, I now got down to 2x times 5. I know that's horrible form, but we want to see it. Plus 3 times 5 equals 7. Okay, what would you do next to be able to go through and solve the blue equation? Well, we're going to get rid of this 15 to be able to isolate our variable term. So let's get rid of our 3 log 5 to isolate our variable term. That's going to give me, and now on the right side, I need to subtract 3 log 5. Okay, we get to that point in the blue, and I just want you to notice that I'm going to write down a line as if you couldn't collect the 7 and the 15. Because notice, we can't collect the log 130 minus 3 log 5. Okay, what would you do next to be able to solve the blue equation? Well, we're going to now have to take everything attached to the x, the 2 and the 5, and since they're attached through multiply, we're going to have to divide it out. So let's take everything attached to that x, and let's divide it out. And so now my x is isolated, and I have a really ugly log 130 minus 3 log 5, now all divided by 2 log 5. There we go. We are all done. I just want to draw to your attention one key thing. I'm going to simplify my blue equation now a little bit, at least to that. And I just want to draw to our attention. I know that there is nobody who goes, hey, I can divide out a common factor of 5 from there. Because you notice that on top, you have 2 terms. And the only way you can divide out a common factor is if you divide it out of all terms. So no one is going to think, hey, I can divide out a log 5 here. No, because it's not going to divide into log 130. For anybody who says, but wait a second, 5 goes into 130, be careful. There is no 130 on that top. It is a log 130. So what you end up seeing then in that final red expression is our final simplified form. Okay, now we're going to jump into some stuff that gets a little bit uglier as we go. The exact same process we worked through in red. Okay, so let's take a look at D. And as we work our way through D, first thing we notice, I have my variable up in my exponent. I've got to get it out. Now, it's not that easy to write 6 and 4 as powers of the same base, and so I'm going to take the log of both sides. We would need to see this line every time. We understand that your whole goal is to get that exponent out. However, I cannot come up with this line unless the previous line was there. So you've got to show me both of those lines. Now that I've got that, I've actually solved my problem. I now just need to solve the equation. I want you to take a look on the right side because I can simplify that right side by expanding my brackets. And now I have individual terms. So my job, to be able to go through and solve for x, which means that I need to now collect my x terms. And so I'm going to think about that term coming over. So to get rid of a positive 2x log 4, I need to subtract 2x log 4. And I'm left with my negative 3 log 4 on the right side. Well, you take a look right now and you've got 2 terms both containing an x. I would hope that we would be okay to examine this line. My problem was that I have my x in 2 different spots. And one way that I can get it into one position may be to write it that way. So you could view that as possibly what it looks like I've common factored out an x in both terms. Now, some people go a little too heavy with that, and I just want to draw to your attention, you can view it a different way. Really, all I did was I collected. When you guys learn how to collect like terms, you're often given a problem that looks something like this. And if I was to ask you, well, what's 3a plus 5a? I just want you to notice that really what you do is you take one coefficient, the operation in between the other coefficient, and you say that you have 3 plus 5 a's. You don't view it as common factoring out an a. You simply view it as collecting the coefficient. And so you may choose to view our red equation the same way. Now, what do we like about that? My x is almost all by itself. It's in one spot. And the only thing attached to it now is 3 log 6 minus 2 log 4. It's attached by multiply. So for me to be able to get rid of that multiply, I'm going to divide it out, and I come in right on that line. And there we go. I want you to take a look. You have one term on top, you have two terms on the bottom, and there are no common factors to be able to divide out. I have no common factors in my coefficients, and I have no common logs that I could divide out either. One small note to make at that point, and this is going to be a big jump for us, but we may get to a point where we may encounter the idea of being able to take a log 4 plus a log 2. And I want to draw to your attention that if we see something like that, we can actually simplify that a little further. The reason for it, I can write or think of log 4 as log 2 squared. And now that that's a power inside my log, I can bring that exponent of 2 out in front. And notice, I could create like terms. If I have 2 log 2 plus another log 2, then I have 3 log 2. Just something to be conscious of. In the green instance, if that ever arose, I would expect you to simplify that down to 3 log 2. You would not have to show any work. Okay, now we're going to jump to something that gets a little bit uglier. And this is going to be the ugliest looking problem that you would face. I want you to take a look at both sides of the equation and notice that we have our variable in the exponent. We've got to get it out. Writing a power base 3 and a power base 2 as powers of the same base will be difficult, so we take the log of both sides. When I take the log of both sides, I want you to notice that I'm taking the log of this whole side. Now we may see a bit of a problem. A common mistake is going to arise. And what it's going to be is that we want to bring that exponent out in front. But I want you to notice that I do not have a single power inside my log. I have 4 times a single power. And so since the exponent x plus 4 is not the exponent on everything inside the log, I can't bring it out in front. Now I'd like to just show you what I would end up getting if I did. You would try telling me that that would be x plus 4 times the log of 4 times 3. And if I were able to do that, then couldn't I go through and just multiply the 4 times the 3 up here? And then you hit the brakes, because we recognize that that would be a bedmass mistake. That you can't do multiplication before you do exponent. And so we can see that all of that green is incorrect. So, for us to go through, what we're going to deal with then is a problem that arises in avoiding that green. Now, I'm just going to go through and clean that up a little bit. There we go. So on the left side, you'll notice that I do have multiplication on the inside. And I know how to break apart a log if I have multiplication on the inside. I know that I can break that up into the addition of two logs. Now, before we jump to the right side, I would like you to notice that on the left side, I have cured my problem. That 3 to the exponent x plus 4 is a single power inside my log. And so we can see the benefit to breaking apart both sides using our properties of logs to get to that. Now, just for uniformity, I may take a look and say, I'm going to bring this exponent down. At the same time, I'm going to bring this exponent down. If you'll take a look at that line, you'll notice that that's like a line in the previous solution. So I would like everybody to pause this solution, finish off the solution, and we'll see if we match up. Okay, welcome back. I'm hoping that our first line was to go through and expand the brackets. We now have this really ugly looking equation with a lot of terms. We now have that equation, and I notice I have an x term here and an x term here. I notice that I have a constant, a constant, a constant, and a constant. So I got a lot of stuff. Well, the first thing I might want to do is get all of my x terms on one side. I would hope that we would be okay to think of our x terms on the left side and factor out the common factor of x, or collect those terms all in one step. So notice my green underlined term on the right side, 3x log 2. For me to get rid of a plus 3x log 2, I need to minus it, and that's why we see the minus in between. On the right side, I already have a log 5. I already have a negative log 2. And now, on the left side, I want to get this log 4 term out of there, which means to get rid of a positive log 4, I need to subtract log 4. And I also want to get rid of this positive 4 log 3, which means I'm going to subtract 4 log 3. Well, I'm almost done. Now I can get that all by itself, so I can see that I'm going to divide out a log 3 minus 3 log 2. But I want you to notice on top, what I finished discussing in that last problem arises right here. I can collect a log 2 and a log 4. And so when I simplify that top, I've got my log 5, and those two green terms can come together to give me one term. And I can't collect that with a log 3, and there's my final expression. So hopefully we got down to the same thing, and everybody matches up, and we're good. Okay, what I want to take a look at now is kind of a unique situation. And it's a case where you see an equation like this. Our variable's up in the exponent. For us to solve it, we got to get it out. And we may be tempted to go through and say, I'm going to now take the log of both sides. I just want to draw to your attention a couple key things. I'm not even going to look at the right side. That when you take a look at that left side, you do not have the means to simplify it. Some people make the mistake, and when they take the log of both sides, they want to take the log of both terms. And we should clearly be able to see why this last red line does not represent the first red line. That if I had addition in between two logs, then that should have meant that I had multiplication inside my log. And clearly, we didn't. We had addition. So make sure that when we take the log of both sides, we don't mistake that for the log of each term. Now, your next question might be like, well, then how would I solve this? And I'm going to tell you, you don't have the means to solve it. That really for us, what we would need to do is we would need to graph what that function looks like and graph what that function looks like and then look for the point of intersection. We wouldn't have an algebraic means to solve that. Now, you may say to yourself, then why are you even showing me this if I don't have the means to solve it? And this is where I come back to what we discussed about segmenting your knowledge. I'm going to put an equation down, and this is one that we worked through on the very first day of exponential equations. And you take a look at that solution or that equation, you have to get the variable out of the exponent, which means you take the log of both sides. And now you take the log of each term, and all of a sudden you go, oh, shoot, right. We end up making a huge mistake on an equation like that one. Just remember, you were able to solve that equation by factoring out the smallest power of 2, by then being able to calculate what's on the inside, dividing that out, and now I can't write 6 as a power base 2. I'm going to take the log of both sides, bring down my exponent, and so on. So be very, very careful. And this is where I said about segmenting your knowledge. That I have multiple terms in the equation that I do have the means to solve. So let's make sure that we don't always go, just take the log of both sides and make that our default position. We have to see how many terms do I have in the equation and let that dictate my strategy. Okay, moving forward, now what you want to do is be able to jump in and get as much practice as you can to feel comfortable. Okay, good luck, everybody.